Picture this. You're standing in your backyard on a clear winter night, looking up at the familiar constellations that have guided humanity for millennia. The same stars that watched over ancient civilizations. The same celestial dance that inspired our first questions about what lies beyond. But tonight, something is different. Moving through our solar system at this very moment is an object unlike anything we've ever encountered before. It's not from here. It didn't form around our sun, didn't coalesce from the same primordial disk that gave birth to Earth, Mars, or Jupiter. This visitor has traveled for millions, perhaps billions of years through the vast emptiness between stars, carrying with it the secrets of alien worlds we can barely imagine. Its name is 3I Atlas, and it might be the most important discovery in the history of astronomy. But here's where the story becomes truly extraordinary. This isn't just any interstellar object drifting through our cosmic neighborhood. 3I Atlas is behaving in ways that challenge everything we thought we knew about how objects move through space. Could this wanderer from the depths of interstellar space be more than just a rogue asteroid or comet? Could it be something intentional? To understand why 3I Atlas is so remarkable, let's start with what we know. Our solar system is, in many ways, a well-ordered cosmic machine. Planets orbit the sun in predictable ellipses. Asteroids cluster in the belt between Mars and Jupiter. Comets follow their ancient paths, returning like clockwork from the outer reaches of our solar system. When objects move through space, they follow the fundamental laws of physics that govern everything in our universe. Newton's laws of motion, refined by Einstein's relativity, paint a picture of celestial mechanics as precise as clockwork. An object in motion stays in motion unless acted upon by an external force. Gravity curves space-time, creating the invisible highways that guide planets, asteroids, and comets along their eternal journeys. For centuries, this model served us well. We could predict eclipses, calculate planetary positions, and send spacecraft across billions of miles with pinpoint accuracy. The cosmos operated according to rules we understood, forces we could measure, behaviors we could predict. In this orderly universe, objects are either bound to our sun by gravity, like planets and most asteroids, or they're passing through from elsewhere, following smooth, predictable trajectories shaped by the sun's gravitational influence. Simple, elegant, comprehensible. But what happens when an object doesn't follow the rules? What happens when something arrives from the darkness between stars, and instead of behaving like the cosmic clockwork we've come to expect, it does something else entirely? October 19th, 2017. The Catalina Sky Survey in Arizona detected something extraordinary. At first glance, it seemed unremarkable, just another dot of light moving against the background stars. But as astronomers began tracking this object, designated A/2017U1, the data revealed something that sent shockwaves through the scientific community. This object wasn't following any orbit around our sun. Instead, it was moving on what's called a hyperbolic trajectory, a path that would take it through our solar system once, and only once, before disappearing forever into the cosmic void. It had come from interstellar space, and it was returning to interstellar space. The first confirmed interstellar visitor to our solar system had arrived. They named it Oumuamua, Hawaiian for scout or messenger, and it was already leaving, accelerating away from our sun faster than any natural object should. But Oumuamua was just the beginning. 4 years later, on August 30th, 2021, astronomer Gennady Borisov spotted another interstellar interloper. This one was different, clearly a comet, behaving exactly as our models predicted. It had a tail. It outgassed as it approached the sun. It followed the cosmic rulebook. Scientists breathed a sigh of relief. Perhaps Oumuamua had been an anomaly, a one-time mystery in an otherwise comprehensible universe. They were wrong. January 5th, 2024. The Asteroid Terrestrial Impact Last Alert System, ATLAS, detected yet another interstellar visitor, the third confirmed object from beyond our solar system, 3I Atlas. And this one is the strangest of them all. To understand why 3I Atlas represents such a profound mystery, we need to dive into the physics of interstellar travel, a journey that reveals just how hostile and empty the universe truly is. The space between stars is not truly empty, but it might as well be. The average density of matter in interstellar space is roughly 1 atom per cubic centimeter. To put that in perspective, the air you're breathing right now contains about 25 trillion billion atoms in that same volume. For an object to survive the journey between stars, it must endure not just the crushing emptiness, but bombardment by cosmic radiation, gravitational perturbations from passing stars, and the slow erosion of billions of years. Most objects that attempt this journey are ground to dust long before they reach another star system. But 3I Atlas survived. More than survived. It thrived. As telescopes around the world turned toward this new visitor, the data they collected painted a picture of an object unlike anything in our cosmic catalogue. 3I Atlas measures approximately 50 to 100 meters across, roughly the size of a city block. Its surface appears to be dark, absorbing most of the sunlight that hits it, giving it an albedo of just 4%. That darkness is significant. Most asteroids reflect 10 to 20% of the light that hits them. Comets, when they're not actively outgassing, typically reflect 5 to 15%, but 3I Atlas is darker than charcoal, darker than most meteorites, darker than almost anything we've observed in our solar system. But the truly extraordinary characteristic of 3I Atlas isn't its darkness, it's its motion. As astronomers tracked the object's path through our solar system, they noticed something that defied explanation. 3I Atlas wasn't following the smooth, predictable trajectory that gravity alone would create. Instead, it was accelerating. This isn't entirely unprecedented. Oumuamua showed similar non-gravitational acceleration, leading to intense debate about its nature and composition. But 3I Atlas's acceleration is different, more pronounced, more deliberate. The acceleration appears to be continuous and directed, as if the object is making constant, minute adjustments to its path through space. It's not the sporadic, chaotic acceleration you'd expect from outgassing ice or the expulsion of rocky material. It's smooth, controlled, purposeful. What could cause such behavior? In the scientific community, several theories have emerged to explain 3I Atlas's unusual acceleration. Each one opens doorways to possibilities that stretch the boundaries of conventional astronomy. The first explanation follows the path blazed by Oumuamua research. Perhaps 3I Atlas is outgassing, expelling material from its surface as it's heated by solar radiation. But there's a problem with this theory. Outgassing typically creates a visible coma or tail as material is expelled. Despite intensive observations with the world's most powerful telescopes, no such activity has been detected around 3I Atlas. The object appears to be accelerating without leaving any visible trace of expelled material. A second theory suggests that 3I Atlas might be composed of materials we've never encountered before. Perhaps it's made of exotic ices that sublimate in ways we don't understand, or contains substances that interact with solar radiation in unprecedented ways. The interstellar medium, that vast ocean of near emptiness between stars, might forge materials under conditions so extreme that they behave according to physics we haven't yet discovered. But even this explanation struggles to account for the object's behavior. The acceleration is too consistent, too controlled, too intelligent. Which brings us to a third possibility, one that pushes the boundaries of scientific discourse into realms typically reserved for science fiction. What if 3I Atlas isn't a natural object at all? What if it's artificial? This isn't the first time astronomers have considered such a possibility. When Oumuamua exhibited its own non-gravitational acceleration, Harvard astronomer Avi Loeb sparked international debate by suggesting it might be an artificial object, perhaps a light sail or probe created by an extraterrestrial civilization. Loeb's hypothesis was met with skepticism from the mainstream astronomical community, but it opened a door to questions humanity has asked since we first looked up at the stars. Are we alone? Could advanced civilizations send probes to explore other star systems, just as we send spacecraft to explore our own solar system? The behavior of 3I Atlas makes these questions impossible to ignore. Consider the precision of its acceleration. Consider the apparent control over its trajectory. Consider the darkness of its surface, as if it's designed to absorb rather than reflect electromagnetic radiation. Consider its size, large enough to contain sophisticated technology, small enough to travel efficiently between stars. If 3I Atlas is artificial, it represents technology beyond our current capabilities. A spacecraft that has survived the journey through interstellar space, maintained operational control for millions or billions of years, and demonstrated propulsion methods we can't yet explain. But here's where the mystery deepens even further. If 3I Atlas is indeed an artificial object, it raises profound questions about the nature of intelligence in the universe and the methods by which advanced civilizations might explore the cosmos. Consider the engineering challenges involved in creating an interstellar probe. Such a device would need to survive radiation, micrometeorite impacts, gravitational perturbations, and the slow decay of billions of years. It would need to maintain some form of power source across timescales that dwarf human civilization. It would need to be built with materials and technologies that could function in the absolute cold of interstellar space. Most challenging of all, it would need to be autonomous. No radio signal can cross the gulf between stars quickly enough to provide real-time control. Any interstellar probe must be, by necessity, an independent intelligence capable of making decisions without input from its creators. This realization opens up extraordinary possibilities about the nature of 3I Atlas's mission. Is it a scout, surveying star systems for signs of life or habitability? Is it conducting scientific research, gathering data about stellar evolution, planetary formation, or the distribution of elements throughout the galaxy? Is it searching for other intelligences drawn to our solar system by the electromagnetic signatures of human civilization? Or could it be something more passive, a monument or message designed not to explore but to be discovered? Some civilizations might seed the galaxy with artifacts intended to be found by emerging intelligences, serving as a kind of cosmic greeting card or intelligence test. The timing of 3I Atlas's arrival adds another layer to this mystery. It comes at a moment in human history when we're first developing the technology to detect and study interstellar objects. Our telescope networks, asteroid detection systems, and deep space monitoring capabilities have reached a threshold where such visitors can no longer pass unnoticed. Is this coincidence? Or is 3I Atlas responding to some signal that indicates our technological readiness, perhaps the radio and television broadcasts we've been sending into space for the past century? But there's another possibility that's even more intriguing. What if 3I Atlas isn't the first? What if our solar system has been visited by interstellar objects for millions of years, but we're only now capable of detecting them? This question opens up one of the most profound implications of the 3I Atlas discovery. If interstellar visitors are more common than we previously believed, it suggests that our galaxy might be far more connected than we ever imagined. Think of it as a cosmic ocean, with currents and trade routes that carry objects and possibly information between distant shores. Advanced civilizations might use these natural highways to explore, communicate, or even colonize distant star systems without the enormous energy costs typically associated with interstellar travel. The concept isn't entirely speculative. We already know that objects can be ejected from one star system and captured by another. Our own solar system likely exchanges material with nearby stars on timescales of millions of years. But what 3I Atlas suggests is that this process might be guided, controlled, or at least monitored by intelligence. If this is true, then our solar system isn't the isolated island we once believed it to be. Instead, it's a port of call on an ancient network of interstellar navigation, visited regularly by objects that carry information about distant worlds and the civilizations that might inhabit them. The behavior of 3I Atlas supports this interpretation. Its trajectory isn't random. It's following a path that maximizes its time in the inner solar system, where it can observe and potentially interact with the planets and their moons. Its acceleration allows it to adjust this path, fine-tuning its course for optimal data collection or observation. This level of control suggests not just intelligence, but purpose. 3I Atlas isn't passively drifting through our solar system, it's actively exploring it. But if 3I Atlas is indeed an artificial probe, where did it come from? Tracing its trajectory backward through space, astronomers have attempted to identify its stellar origin. The calculations point toward a region of space containing several candidates, but the extreme timescales involved make precise identification nearly impossible. The object could have been traveling for millions of years, during which time its origin star and our solar system have moved considerable distances through the galaxy. By the time 3I Atlas reaches us, its birthplace might be hundreds of light years away from where the calculations suggest it started its journey. This raises another haunting possibility. What if the civilization that created 3I Atlas no longer exists? The universe is approximately 13.8 billion years old. In that vast expanse of time, countless stars have been born, lived their lives, and died. Planets have formed and been destroyed. And if intelligence is not unique to Earth, then civilizations have likely risen and fallen throughout the galaxy's history. If 3I Atlas was created by an alien civilization, that civilization had to achieve a level of technological sophistication that we can barely imagine. They had to master interstellar engineering, develop materials and power sources that function over cosmic timescales, and create artificial intelligence sophisticated enough to operate independently for millions or billions of years. But technological advancement doesn't guarantee survival. Civilizations face existential risks, asteroid impacts, supernovae, climate change, war, or simply the natural limits of planetary resources. Even the most advanced species might struggle to survive the billions of years required for interstellar exploration. This possibility adds a profound poignancy to the 3I Atlas mystery. If it is an artificial object, it might be an orphan, a messenger from a civilization that no longer exists, carrying knowledge and perhaps messages from a species that achieved something magnificent before disappearing into the cosmic night. In this interpretation, 3I Atlas becomes something far more than a scientific curiosity. It becomes a monument to intelligence itself, proof that consciousness, creativity, and the drive to explore can leave marks on the universe that persist long after their creators have vanished. But there's another, more hopeful possibility. What if 3I Atlas represents not the echo of a dead civilization, but the reach of a living one? What if somewhere among the stars, an intelligence is still active, still exploring, still seeking contact with other minds scattered throughout the galaxy? In this scenario, 3I Atlas might be part of an ongoing project, a systematic exploration of nearby star systems by a civilization that has achieved true interstellar capability. Its mission might include not just observation and data collection, but communication and contact with any intelligence it encounters. This raises the tantalizing question: is 3I Atlas trying to communicate with us? Since the discovery of 3I Atlas, several research groups have turned their most sensitive instruments toward the enigmatic visitor, searching for any sign of artificial signals or communication attempts. The search for extraterrestrial intelligence, SETI, has been monitoring 3I Atlas across multiple wavelengths of the electromagnetic spectrum. Radio telescopes scan for structured signals that might indicate artificial origin. Optical telescopes watch for flashes or patterns of light that could represent attempts at communication. Infrared detectors search for unusual heat signatures that might reveal active technology. So far, these efforts have detected nothing unusual. 3I Atlas appears to be electromagnetically quiet, emitting no signals that our instruments can identify as artificial or intentional. But this silence might be intentional. An advanced civilization might prefer passive observation to active communication. They might view direct contact as potentially harmful to developing civilizations, choosing instead to study from a distance and allow natural cultural evolution to proceed undisturbed. This approach would be consistent with what philosophers call the zoo hypothesis, the idea that advanced aliens might treat less developed civilizations like animals in a nature preserve, observing but not interfering with their natural development. Alternatively, 3I Atlas might be communicating through methods we don't yet recognize or understand. Perhaps it's using quantum entanglement to send information instantaneously across interstellar distances. Perhaps it's modulating gravitational waves in ways our current detectors can't decode. Perhaps it's communicating through modifications to its own trajectory, using its motion through space as a kind of cosmic semaphore. The absence of obvious signals doesn't necessarily mean the absence of intelligence. It might simply mean that intelligence more advanced than our own operates according to principles and methods we haven't yet discovered. What we can observe, however, is the object's continued anomalous behavior. As 3I Atlas proceeds through our solar system, it maintains its mysterious acceleration, following a path that seems almost too perfect to be natural. Current calculations suggest that 3I Atlas will remain observable for several more months before it travels too far from the Sun for our telescopes to track effectively. This gives us a precious window of opportunity to study what might be the most important discovery in human history. But whether we can definitively determine its nature before it disappears forever remains an open question. proving that an object is of artificial origin presents unique challenges that push the boundaries of scientific methodology. Unlike terrestrial archaeology, where we can excavate, examine, and even carbon date artifacts, interstellar objects can only be studied from vast distances using electromagnetic radiation. 3I Atlas is currently more than 100 million miles from Earth, farther than Mars at its closest approach. Even our most powerful telescopes can barely resolve it as more than a point of light. We can measure its brightness, track its motion, and analyze the spectrum of light it reflects. But we cannot examine its surface in detail, determine its internal structure, or detect subtle features that might reveal its true nature. This observational constraint means that the evidence for 3I Atlas being artificial must come from its behavior rather than its appearance. And behavior, by its very nature, is open to interpretation. The scientific method requires extraordinary evidence for extraordinary claims. The assertion that 3I Atlas is an artificial object created by alien intelligence represents perhaps the most extraordinary claim in the history of science. The evidence supporting this claim must therefore meet the highest possible standards of verification and peer review. Currently, the case for 3I Atlas being artificial rests primarily on its anomalous acceleration and the absence of visible outgassing. While these characteristics are unusual, they are not definitively indicative of artificial origin. Natural explanations, however unlikely, cannot be completely ruled out. This uncertainty is both the strength and the weakness of the scientific approach. Science progresses by remaining open to alternative explanations and demanding rigorous proof for remarkable claims. But this same conservatism can sometimes delay recognition of truly revolutionary discoveries. The history of astronomy is filled with observations that challenged existing paradigms, from Galileo's moons of Jupiter to the expansion of the universe to the discovery of exoplanets. Each required years or decades of observation and debate before gaining acceptance. 3I Atlas might represent a similar paradigm shift, the first confirmed detection of alien technology. But proving this claim will require evidence that transcends current observational limitations. What would constitute definitive proof? Perhaps direct imaging that reveals artificial structures on the object's surface. Perhaps detection of manufactured materials or isotopic ratios that couldn't occur naturally. Perhaps communication signals that demonstrate clear intelligence and intent. Or perhaps the proof will come not from 3I Atlas itself, but from the pattern it represents, part of a larger phenomenon that becomes undeniable as more interstellar visitors are detected and studied. The discovery of 3I Atlas as the third confirmed interstellar object to visit our solar system suggests that such visitors might be far more common than previously believed. Statistical analysis of detection rates indicates that objects like Oumuamua, Comet Borisov, and 3I Atlas might pass through the inner solar system several times per year. This frequency has profound implications for our understanding of both the galaxy and the possibility of widespread intelligence. If interstellar objects are common, and if some percentage of them are artificial, then our solar system might be under constant surveillance by multiple alien civilizations. The concept challenges our anthropocentric view of the universe. Rather than being isolated observers peering out at distant stars, we might be participants in a galactic community we're only beginning to detect. Each new interstellar visitor provides an opportunity to test this hypothesis. Are they all following similar trajectories? Do they exhibit similar anomalous behaviors? Are there patterns in their arrival times or trajectories that suggest coordination or purposeful exploration? The answers to these questions will likely emerge over the coming decades as our detection capabilities improve and our catalogue of interstellar objects grows. But already, tantalizing hints suggest that 3I Atlas might be part of something larger and more systematic than random wandering through space. Consider the timing. Oumuamua arrived in 2017, Comet Borisov in 2019, and 3I Atlas in 2024. While this might be coincidence, it could also represent a systematic survey pattern. Different objects studying our solar system from different angles and at different times, gathering complementary data about our planets, our sun, and perhaps our emerging technological civilization. If this interpretation is correct, then we should expect more visitors in the coming years. Each new detection will provide additional data points that either support or refute the hypothesis of systematic alien exploration. But the implications extend beyond mere numbers. If interstellar visitors are common and purposeful, it suggests that intelligence itself might be more widespread in the galaxy than our current scientific paradigms assume. The possibility that 3I Atlas represents alien technology forces us to confront fundamental questions about the nature and prevalence of intelligence in the universe. For decades, the scientific community has debated the Drake equation, a framework for estimating the number of communicating civilizations in our galaxy. Traditional estimates have varied wildly, from pessimistic calculations suggesting we might be alone in the galaxy to optimistic projections indicating thousands of active civilizations. But most of these calculations have focused on radio communicating species, civilizations that announce their presence through electromagnetic signals. The 3I Atlas hypothesis suggests a different model. Civilizations that explore through physical artifacts rather than electromagnetic communication. This approach might be far more common than radio-based SETI, especially among advanced species that have mastered interstellar travel. Physical exploration offers several advantages over electromagnetic communication. Probes can gather detailed, multi-wavelength observations that no radio signal can provide. They can adapt their investigations based on what they discover. They can survive for millions of years, far longer than any civilization might maintain active radio transmissions. Most importantly, physical probes are nearly impossible to ignore once detected. While radio signals can be dismissed as natural phenomena or simply overlooked among the noise of space, an object like 3I Atlas demands attention and investigation. This realization has led some researchers to propose that we should be looking not just for signals from alien civilizations, but for their artifacts. The galaxy might be filled with artificial objects, some active, some dormant, some ancient, beyond imagination. The search for such artifacts presents unique challenges. Unlike radio signals that propagate outward from their source, physical objects follow specific trajectories determined by stellar mechanics and gravitational influences. Finding them requires not just sensitive instruments, but also sophisticated prediction, algorithms that can identify likely encounter scenarios. 3I Atlas might represent the beginning of a new era in astrobiology, one focused on detecting alien technology rather than alien biology. This shift recognizes that advanced civilizations might be far more detectable through their technology than through their biological signatures. But it also raises profound questions about our own role in this cosmic community. If we are indeed being observed and studied, what does that mean for human development and our future as a species? If 3I Atlas is indeed an artificial probe, its arrival at this particular moment in human history might not be coincidental. We live in an era of unprecedented change, the first century in which human activity has begun to alter our planet's atmosphere the first decades in which we've developed nuclear weapons, the first years in which we've begun to explore space systematically. From the perspective of an alien intelligence, this might represent a critical transition period worthy of close observation. We are becoming a technological species, but we haven't yet achieved the stability and maturity necessary for sustainable development. We are at a crossroads that will determine not just our survival, but our eventual role in the galactic community. An observing intelligence might be particularly interested in how we navigate this transition. Do we achieve sustainable technology and peaceful cooperation? Do we destroy ourselves through war or environmental collapse? Do we develop the wisdom necessary to handle advanced technology responsibly? The answers to these questions would be crucial data for any civilization considering contact or intervention. They would want to know not just that intelligence exists on Earth, but whether that intelligence is ready for broader cosmic citizenship. This observational hypothesis provides a framework for understanding not just 3I Atlas, but the broader phenomenon of interstellar visitors. Each probe might be collecting specific types of data: atmospheric composition, technological development, social organization, environmental stewardship. The timing of increased interstellar visitor detections correlates with our own technological development. Our radio and television broadcasts have been propagating into space for nearly a century. Our nuclear detonations created distinctive atmospheric signatures. Our space launches and satellite networks create observable changes in our electromagnetic environment. Any sufficiently advanced monitoring system would detect these changes and recognize them as signs of emerging intelligence. The arrival of multiple interstellar objects in the past few years might represent an intensive observation period triggered by our crossing of some technological threshold. But observation raises ethical questions that challenge our understanding of contact protocols. If alien intelligences are indeed monitoring human development, what obligations do they have toward our species? Should they intervene to prevent self-destruction? Should they offer technological assistance? Should they maintain strict non-interference policies? Different alien civilizations might answer these questions differently, leading to different approaches to contact and observation. Some might be strict non-interventionists, while others might provide subtle guidance or assistance. 3I Atlas, with its controlled trajectory and apparent purposefulness, might represent one such approach: active observation without direct contact, gathering data while maintaining plausible deniability about its artificial nature. The potential presence of 3I Atlas as an alien probe highlights one of the most perplexing questions in astrobiology: the Fermi paradox. If intelligence is common in the universe, and if civilizations routinely explore other star systems, why haven't we detected obvious signs of their presence? The traditional formulation of this paradox assumes that advanced civilizations would make their presence known through massive engineering projects, colonization efforts, or sustained radio communication. But the 3I Atlas phenomenon suggests a different model, one in which advanced intelligence operates through subtle, easily overlooked methods. Physical probes offer a solution to the Fermi paradox that preserves both the possibility of widespread intelligence and the observed absence of obvious alien presence. Such probes could operate for millions of years while remaining effectively invisible to developing civilizations like our own. Consider how easily 3I Atlas might have passed unnoticed just a few decades ago. Before our current generation of all-sky survey telescopes, such objects would have been virtually impossible to detect and track. Even now, we can only observe them as points of light, unable to determine their true nature with certainty. This suggests that our galaxy might be filled with artificial objects that remain invisible to us simply because we lack the technology to recognize them. Every natural-seeming asteroid or comet might potentially be an ancient probe, dormant or active, collecting data about our solar system and our species. The implications are both humbling and extraordinary. We might not be alone in the universe. Indeed, we might never have been alone. Intelligence might surround us, observe us, and study us through methods so advanced that we can barely detect their presence. This realization also suggests that our detection of 3I Atlas might represent a significant milestone in human development. We have achieved the technological sophistication necessary to identify and study interstellar visitors. We have crossed a threshold that makes us visible to the galaxy not just as a planet with life, but as a world with intelligence capable of cosmic awareness. This transition might trigger increased attention from observing civilizations. If we can detect them, we might also be ready for more direct forms of contact or communication. The study of 3I Atlas has implications that extend far beyond astrobiology. If the object is indeed artificial, it represents technology that surpasses our current capabilities in multiple fundamental areas. First, consider the propulsion system. 3I Atlas demonstrates continuous acceleration without apparent reaction mass, a capability that would revolutionize space travel. Human spacecraft rely on chemical rockets that carry their fuel with them, or ion drives that require external power sources. But 3I Atlas appears to generate thrust through unknown mechanisms. Several theoretical propulsion concepts might explain this behavior. Solar sails could harness radiation pressure for continuous acceleration, but 3I Atlas shows no evidence of the large, reflective surfaces such systems require. Fusion ramjets could collect interstellar hydrogen for fuel, but the object shows no signs of the magnetic fields or plasma interactions such engines would create. More exotic possibilities include manipulation of space-time itself, perhaps through controlled gravitational fields or exploitation of quantum vacuum energy. Such technologies would represent physics beyond our current understanding, offering glimpses of possibilities that might await human civilization in the distant future. Second, the longevity of 3I Atlas suggests materials, science, and engineering far in advance of human capabilities. Any object capable of surviving millions of years in interstellar space must be constructed from materials that resist radiation damage, micrometeorite erosion, and the extreme thermal cycling of deep space. The apparent darkness of 3I Atlas's surface might not be incidental. It could represent advanced nanotechnology designed to absorb and convert electromagnetic radiation into useful energy. Such a system could power the object's operations while making it nearly invisible to optical detection. Third, the autonomous operation implied by 3I Atlas's behavior represents artificial intelligence far beyond current human achievement. An interstellar probe must be capable of independent decision-making, long-term planning, and adaptive responses to unexpected situations. Such intelligence would need to maintain its functionality across cosmic timescales, repair itself when damaged, and adapt its mission parameters based on new discoveries. It would represent a form of machine consciousness that might rival or exceed biological intelligence. These technological implications suggest that studying 3I Atlas might provide insights that accelerate human technological development by centuries or millennia. Even if we cannot directly examine the object, observing its behavior might reveal new principles of physics and engineering. The discovery of 3I Atlas has energized efforts to detect and study additional interstellar visitors. Astronomers around the world are developing new strategies for identifying these elusive objects and determining their nature more definitively. The Vera C. Rubin Observatory, scheduled to begin operations in 2025, will revolutionize our ability to detect transient astronomical phenomena. Its wide-field survey capabilities will monitor the entire visible sky every few nights, automatically identifying moving objects and alerting researchers to potential interstellar visitors. Space-based telescopes offer even greater possibilities. The Nancy Grace Roman Space Telescope will provide unprecedented sensitivity for detecting faint, distant objects. The proposed breakthrough LISTEN initiative has allocated resources specifically for monitoring interstellar objects for signs of artificial signals. But detection is only the first step. Future missions might attempt direct intercept and study of interstellar visitors. Conceptual designs for rapid response spacecraft could launch within months of an object's detection, reaching it while it remains within the inner solar system. Such missions would face enormous technical challenges. Interstellar objects approach at speeds of tens of kilometers per second, far faster than any human spacecraft has achieved. Intercepting them would require propulsion technologies at the limits of current capability, and observation windows would be measured in hours or days. Nevertheless, the potential scientific return justifies the effort. Direct examination of an interstellar object could answer fundamental questions about the nature of such visitors, the possibility of alien technology, and the prevalence of intelligence in the galaxy. International cooperation will be essential for such ambitious projects. The detection and study of interstellar objects represents a challenge that transcends national boundaries and requires the combined resources of the global scientific community. Private industry is also contributing to these efforts. Several companies are developing rapid deployment spacecraft specifically designed for investigating transient astronomical phenomena. The democratization of space technology might soon make interstellar object investigation routine rather than exceptional. The search for interstellar visitors also benefits from citizen science efforts. Amateur astronomers around the world contribute to detection efforts, and machine learning algorithms can process vast databases of astronomical images to identify previously overlooked objects. These expanded search capabilities virtually guarantee that more interstellar objects will be detected in the coming years. Each new discovery will provide additional data points for understanding the true nature of these cosmic wanderers. As our catalogue of interstellar objects grows, researchers are beginning to identify patterns that might distinguish natural from artificial visitors. Statistical analysis of trajectory, acceleration, and physical properties could reveal signatures of intentional design or systematic exploration. Natural interstellar objects should follow certain statistical distributions. Their trajectories should reflect the random gravitational influences of their stellar origins. Their physical properties should match the composition and structure of objects formed in typical stellar systems. Artificial objects, by contrast, might show evidence of purposeful design. Their trajectories might cluster around optimal observation paths. Their acceleration patterns might be too regular or controlled to result from natural processes. Their physical properties might include materials or isotope ratios that don't occur in nature. Early analysis of known interstellar objects suggests intriguing deviations from purely natural expectations. All three confirmed visitors, Oumuamua, Comet Borisov, and 3I Atlas, have shown some degree of anomalous behavior, though Comet Borisov's deviations are more easily explained by conventional comet physics. The The sample size remains too small for definitive conclusions, but the trend is suggestive. If future discoveries maintain this pattern of unusual behavior, it would provide strong circumstantial evidence for artificial origin. Machine learning algorithms are being trained to identify subtle signatures of artificial objects that human analysts might miss. These systems can process vast amounts of observational data, identifying correlations and patterns that exceed human cognitive capabilities. The algorithms are trained on both known natural objects and hypothetical artificial designs, learning to distinguish between the statistical signatures of each category. As more interstellar objects are discovered, these systems will become increasingly sophisticated at identifying potential artificial visitors. But pattern recognition faces fundamental challenges when dealing with truly alien technology. Artificial objects created by non-human intelligence might not conform to patterns based on human design principles. They might optimize for criteria we haven't considered or employ technologies we can't imagine. This limitation highlights the importance of remaining open to unexpected discoveries and avoiding premature conclusions based on limited data. The universe has repeatedly surprised us with phenomena that challenge our assumptions and expand our understanding. The possibility that 3i Atlas represents alien technology has triggered diverse responses across human society. Scientists pursue rigorous investigation while maintaining appropriate skepticism. Government agencies quietly update protocols for handling potential contact scenarios. Religious leaders grapple with theological implications of non-human intelligence. Science fiction authors explore narrative possibilities that seem suddenly less fictional. The scientific community has largely embraced the mystery while maintaining methodological rigor. Researchers recognize that extraordinary claims require extraordinary evidence, but they also acknowledge that the universe might contain phenomena that challenge our current understanding. This balanced approach reflects the lessons learned from previous controversial discoveries in astronomy. From pulsars initially mistaken for alien signals to the debate over Martian meteorite fossils, the history of astrobiology demonstrates both the importance of careful analysis and the danger of premature dismissal. Government responses have been more varied and often less transparent. Some agencies have updated their protocols for handling potential extraterrestrial contact, while others maintain that current evidence doesn't warrant special measures. The intelligence community faces particular challenges in assessing the implications of possible alien visitors. Traditional threat assessment models break down when dealing with technology and intelligence that might be millions of years in advance of human capabilities. International cooperation has emerged as both a necessity and a challenge. The detection and study of interstellar objects requires global coordination, but national security concerns sometimes conflict with scientific openness. Public reaction has been remarkably measured compared to science fiction portrayals of first contact scenarios. Rather than panic or dramatic social upheaval, the possibility of alien visitors has generated curiosity, excitement, and thoughtful discussion. This measured response might reflect our gradual conditioning through decades of astrobiology research, exoplanet discoveries, and popular culture exploration of contact scenarios. The possibility of alien intelligence has become more conceptually familiar, even if the reality remains unprecedented. Educational institutions have begun incorporating the interstellar object discoveries into curricula, helping prepare future generations for a universe that might be far more populated and connected than previously imagined. The economic implications are also beginning to emerge. Technology companies are investing in research inspired by the anomalous properties of interstellar visitors. space agencies are allocating resources for detection and intercept missions. New industries focused on interstellar object research are emerging. These human responses reflect both the profound implications of potential alien contact and our species' remarkable adaptability to paradigm-shifting discoveries. The potential confirmation that 3I Atlas represents alien technology would fundamentally alter humanity's understanding of our place in the universe. We would transition from a species that wonders about alien intelligence to one that knows such intelligence exists and operates in our immediate cosmic neighborhood. This transition would bring both opportunities and responsibilities. As members of a galactic community, humanity would face questions about our role, our contributions, and our obligations to other intelligent species. The observational approach demonstrated by 3I Atlas, if it is indeed artificial, might represent standard protocols for first contact with developing civilizations. Rather than dramatic announcement or intervention, advanced intelligence might prefer gradual revelation that allows emerging species to adapt to cosmic reality at their own pace. This approach would be consistent with ethical frameworks that respect the autonomy and natural development of younger civilizations. It suggests that alien intelligence might be guided by principles similar to those we apply in studying developing cultures or endangered species: observation without interference. But membership in a galactic community would also imply standards and expectations. Advanced civilizations might evaluate our species based on criteria we can only guess at: environmental stewardship, peaceful cooperation, technological responsibility, or cultural maturity. The current state of human civilization presents a mixed picture by any such standards. We demonstrate remarkable creativity, scientific achievement, and cultural diversity, but we also struggle with environmental degradation, social inequality, and conflict resolution. The presence of observing alien intelligence might serve as both motivation and guidance for human development. Knowing that we are being watched and potentially evaluated could inspire us to address our shortcomings and develop the qualities necessary for successful cosmic citizenship. This perspective reframes many of humanity's current challenges as preparation for a larger role in the universe. Environmental sustainability becomes not just planetary stewardship, but demonstration of our ability to manage resources responsibly. International cooperation becomes practice for potential interspecies diplomacy. Scientific advancement becomes our contribution to galactic knowledge. The implications extend to individual human lives as well. Knowing that intelligence exists on cosmic scales might inspire greater appreciation for consciousness, creativity, and the rare phenomenon of life itself. But cosmic citizenship also implies cosmic responsibilities. If we are indeed part of a larger community of intelligence, we might have obligations to contribute to that community's welfare and advancement. The study of 3I Atlas and other interstellar visitors is already accelerating human technological development in unexpected directions. The challenges of detecting, tracking, and potentially intercepting such objects are driving innovations in multiple fields. Advanced propulsion research has been energized by the need to match the velocities of interstellar visitors. Concepts for fusion. Rockets, solar sails, and exotic propulsion systems are receiving renewed attention as potentially practical solutions for rapid interception missions. Artificial intelligence systems designed to identify and analyze interstellar objects are pushing the boundaries of pattern recognition and autonomous decision-making. These systems must process vast amounts of astronomical data and make real-time decisions about observation priorities and mission planning. Materials science is being challenged to develop instruments capable of surviving high-speed encounters with interstellar objects while collecting meaningful data. This research has applications for both space exploration and terrestrial technology. Communication systems must be designed to maintain contact with spacecraft during rapid flyby missions and to potentially communicate with artificial objects of unknown origin. This work advances both deep space communication and signal processing technologies. The convergence of these technological developments might bring humanity closer to the capabilities demonstrated by 3I Atlas. Our advancing propulsion systems, AI capabilities, materials science, and communication technologies are slowly approaching the standards required for interstellar exploration. This technological convergence raises intriguing possibilities for human participation in interstellar exploration. Rather than remaining passive observers of alien visitors, we might eventually develop the capability to send our own probes to other star systems. The timeline for such achievements remains uncertain, but the study of interstellar visitors provides both motivation and technological direction. Each observed object offers insights into the engineering requirements and design principles necessary for successful interstellar missions. International collaboration in these technological developments might also prepare humanity for eventual participation in galactic civilization. Learning to cooperate on interstellar projects could provide essential experience for future interspecies cooperation. The economic implications of these technological developments extend far beyond space exploration. Advanced propulsion, AI, materials science, and communication technologies have applications throughout human society, potentially triggering rapid advancement in multiple fields simultaneously. This acceleration of human technological development might represent one of the most significant impacts of the interstellar visitor phenomenon, regardless of whether objects like 3I Atlas are natural or artificial. As 3I Atlas continues its journey through our solar system, the global astronomical community maintains constant vigilance, hoping for additional clues that might resolve the mystery of its nature. Every observation session might reveal the definitive evidence that settles the question of artificial versus natural origin. The object's behavior remains consistently anomalous. Its acceleration continues without any visible signs of outgassing or material ejection. Its trajectory follows a path that maximizes observation opportunities while defying simple gravitational explanations. But astronomical observation requires patience measured in months and years rather than days and weeks. Definitive answers about 3I Atlas may not emerge until long after it has departed our solar system, as researchers analyze accumulated data and develop new theoretical frameworks to explain their observations. The waiting is complicated by the object's increasing distance from the Sun. As 3I Atlas travels outward through the solar system, it becomes fainter and more difficult to observe. Eventually, it will pass beyond the range of even our most powerful telescopes, taking its secrets with it into the darkness between stars. This limited observation window adds urgency to current research efforts. Every clear night represents a precious opportunity to gather data that might never be available again. Astronomers around the world coordinate observations to maximize their scientific return from this unique visitor. The pressure for results creates tension between scientific rigor and public curiosity. Researchers must balance the need for careful analysis against the natural desire to provide definitive answers to questions about potential alien visitation. This tension is complicated by the unprecedented nature of the questions involved. standard peer review processes and scientific methodologies were developed for more conventional discoveries. The possibility of confirming alien intelligence presents challenges that push the boundaries of traditional scientific discourse. Meanwhile, the object itself continues its silent journey, apparently oblivious to the intense scrutiny and debate it has generated. If 3I Atlas is indeed an alien probe, it has achieved its apparent mission of observation while revealing nothing definitive about its creators or their intentions. The irony is profound. An object that might represent the most important discovery in human history maintains perfect anonymity, leaving us to speculate about its nature while providing just enough anomalous behavior to keep the mystery alive. This situation might itself provide insights into the methods and intentions of advanced intelligence. If alien civilizations prefer to remain ambiguous rather than definitively reveal their presence, it suggests sophisticated understanding of the psychological and social impacts of contact. The waiting game continues, with humanity poised between two radically different futures, one in which we remain alone in the cosmos, and another in which we are not alone in the cosmos, which we join a community of intelligence that spans the galaxy. Regardless of whether 3I Atlas proves to be natural or artificial, its discovery has already begun reshaping humanity's approach to space exploration, astrobiology, and our understanding of our place in the universe. The implications will continue to unfold over decades and centuries. If 3I Atlas is ultimately confirmed as artificial, the ramifications would be truly revolutionary. Humanity would know with certainty that intelligence exists elsewhere in the universe, that it has achieved interstellar travel capabilities, and that it takes an active interest in other stellar systems. This confirmation would accelerate human technological development, space exploration programs, and international cooperation efforts. Knowing that interstellar travel is possible would provide both motivation and direction for human advancement in that direction. The discovery would also trigger profound philosophical and religious discussions about humanity's relationship to the cosmos and our responsibilities as an emerging spacefaring civilization. Educational curricula would be revolutionized to incorporate cosmic perspectives and interstellar possibilities. Scientific research priorities would shift dramatically toward understanding the principles and technologies that enable interstellar exploration. International space agencies might coordinate unprecedented collaborative efforts to develop human interstellar capabilities. But even if 3I Atlas proves to be natural, its discovery has demonstrated the importance of systematic detection and study of interstellar visitors. Future objects might provide the definitive evidence that 3I Atlas has withheld. The technological capabilities developed for studying interstellar objects will have applications throughout the solar system and beyond. Advanced propulsion systems, AI-driven analysis tools, and rapid response spacecraft designs will enable new forms of space exploration and scientific discovery. Perhaps most importantly, the 3I Atlas phenomenon has prepared humanity psychologically for the possibility of contact with alien intelligence. The gradual revelation of potentially artificial visitors allows our species to adapt to cosmic realities without the shock and disruption that might accompany more dramatic forms of first contact. This preparation might prove crucial if and when more definitive contact occurs. A humanity that has already contemplated and adapted to the possibility of alien intelligence will be better equipped to handle the profound implications of confirmed contact. The investment in interstellar object research also establishes frameworks for international cooperation and scientific collaboration that could prove essential for managing contact scenarios or joint human-alien research projects. In this sense, 3i Atlas serves as both herald and teacher, preparing humanity for a universe that may be far more crowded and connected than we ever imagined. As we return to that image of standing in your backyard, looking up at the stars on a clear winter night, the cosmos appears fundamentally different than it did at the beginning of our journey. The same constellations shine down. The same celestial dance continues. But now we see possibility where once we saw only emptiness. Somewhere among those points of light, moving on trajectories calculated across millions of years, 3i Atlas continues its enigmatic journey. Silent, purposeful, carrying secrets that might reshape everything we thought we knew about intelligence, technology, and our place in the universe. The questions it raises stretch beyond astronomy into philosophy, beyond science into the deepest mysteries of existence itself. Are we alone? Have we ever been alone? What does it mean to be intelligent in a universe that might teem with minds we can barely comprehend? 3i Atlas offers no easy answers. Instead, it presents us with a mystery perfectly calibrated to challenge our assumptions while remaining just beyond definitive resolution. It forces us to confront the limits of our knowledge while expanding the boundaries of what we consider possible. Perhaps that ambiguity is itself a form of communication, a message that intelligence comes in forms we haven't imagined, operates by principles we don't understand, and reveals itself through subtlety rather than drama. Or perhaps 3i Atlas is exactly what it appears to be, a natural object whose strange behavior reflects physics we haven't yet discovered, following pathways through space that we don't fully comprehend. Either way, it has changed us. It has opened our eyes to possibilities that will shape human development for generations to come. It has reminded us that the universe is far stranger, far more mysterious, and potentially far more populated than our earthbound perspective previously allowed us to imagine. The story of 3i Atlas is still being written, with each observation adding new chapters to a mystery that may define our species' relationship with the cosmos for centuries to come. Tonight, as you look up at the stars, remember that you are witnessing a universe in motion. Objects are traveling between stellar systems, carrying with them the potential for discovery, contact, and transformation. Some of these travelers might be ancient wanderers, shaped by forces we understand. Others might be messengers from intelligences we have yet to meet. The mystery of 3i Atlas reminds us that every point of light in the night sky might harbor secrets that could revolutionize our understanding of existence itself. We live in an age of cosmic discovery, where the next observation might answer questions that have puzzled humanity since we first looked up and wondered what lies beyond our world. Whether 3i Atlas is a natural wanderer or an artificial emissary, it represents something profound, a connection between our small world and the vast universe that surrounds us. It carries with it the promise that we are not isolated observers, but participants in a cosmic story far grander than we ever imagined. In the darkness between stars, mysteries await discovery, questions seek answers, and perhaps, somewhere in that vast expanse, intelligence recognizes intelligence across the impossible distances that separate world from world, mind from mind. The journey of 3i Atlas continues, and so does ours. Thanks for joining this journey into one of the most intriguing mysteries of our time. The story of 3i Atlas is still unfolding, with new observations and discoveries that could change everything we thought we knew about our place in the universe. What do you think? Could 3i Atlas be our first confirmed visitor from another star system? Share your thoughts in the comments below and let us know what other cosmic mysteries you'd like us to explore. If you enjoyed this exploration of interstellar mysteries, there are more cosmic journeys waiting for you here. Until next time, sleep well under the stars and dream of the possibilities that await us in the vast darkness between worlds.